Hi sir, myself T. Kaushik Reddy from CSE B section. My roll number is 70 and my topic of physics of a tech talk is delta star transformation approach for reliability evaluation. So let's start. So delta star resistance conversion formula. R1 is delta and star. So on your left hand side, we have a formula for delta, that is nothing but R1 is equal to RA plus RB plus RB plus RC plus RA plus RC by RC, nothing but resistance of A, B, C, and R2 is resistance of A, resistance of B plus resistance of B, resistance of C plus resistance of A plus, sorry, into resistance of C by resistance of B. Similarly, resistance of 3, if resistance of A is equal to B is equal to C is equal to star, then R delta is equal to 3R star. If all three resistance A, B, C are equal, then R delta is equal to 3R star. Next, RA is equal to R1, R2 by R1 plus R2 plus R3. RB is equal to R1, R3 plus R1 plus R2 plus R3. RC is equal to R1, R2, R3 by R1 plus R2 plus R3. If R1 is equal to R2 is equal to R3 is equal to R delta, then R star is equal to R delta by 3. So R1 is equal to RB, RC by RA plus RB plus RC. R2 is equal to RA, RC by RA plus RB plus RC. R3 is equal to RA, RB by RA plus RB plus RC. So what is delta star transformations? Let's start. The replacement of delta or mesh by equivalent star connection is known as delta star transformation. The two connections are equivalent or identical to each other if the impedance is measured between any pair of lines. That means the value of impedance will be the same if it is measured between any pair of lines, irrespective of whether the delta is connected between the lines or its equivalent star is connected to between the lines. So we have a diagram of delta and star connected resistors. A, B, C are the points marked, and R1, R2, R3 are the resistors on the left hand side, and on the right hand side, A, B, C are the points again, and RA, RB, RC are the resistors. On the left hand side, this is a delta, and on the right side is a star. Both are delta and star connected resistors. So derivation. Consider a delta system that has three corners points are A, B, C as shown in the figure. On the figure is nothing but this. This is a figure where A, B, C are pointed at the corners. Electrical resistance of the branch between points A, B, and C and A are nothing but A, in between A and B there is a resistance R1, and between B and C there is a resistance R2, and between C and A resistance R3. So between points A and B and C and A are R1, R2, R3 respectively. The resistance between the points A and B will be, so the resistance between A and B, nothing but R1 is equal to RAB is equal to R1. R2 plus R1 is equal to R1 into R2 plus R3 by R1 plus R2 plus R3. Now one star system is connected to these points A, B, and C as shown in the figure. Three arms RA, RB, RC of the star system are connected with A, B, C respectively. Now, if we measure the resistance value between points A and B, we'll get RAB is equal to resistance of A plus resistance of B. Since two systems are identical, resistance measured between terminals A and B in both systems must be equal. R resistance of A plus resistance of B is equal to resistance of 1 into resistance of 2 plus resistance of 3 by R1 plus R2 plus R3. Similarly, resistance between points B and C being equal in the two systems, RB plus RC is equal to R2 into R3 plus R1 by R1 plus R2 plus R3. And resistance between points C and A being equal in the two systems is equal to RC plus R1 is equal to R3 into R1 plus R2 by R1 plus R2 plus R3. So if we add all the three equations from this slide, RA plus RB are the three equations, we get 2 into RA plus RB plus RC equal to 2 into R1 R2 plus R2 R3 plus R3 R1 by R1 plus R2 plus R3. So RA, so if we here we have a mathematical calculation. If we cancel 2 and 2, we get RA plus RB plus RC is equal to R1 R2 plus R2 plus R2 R3 plus R3 R1 by R1 plus R2 plus R3. This is the equation we got when we added all the three equations in the in the previous slide. If we subtract these equations 1, 2, 3, then let's see what happens. RA is equal to R3 R1 by R1 plus R2 plus R3. RB is equal to R1 R2 by R1 plus R2 plus R3. RC is equal to R2 R3 by R1 plus R2 plus R3. The relation of delta star transformation can be expressed as follows. The equivalent star resistance connected to a given terminal is equal to the product of two delta resistance connected to the same terminal divided by the sum of the connected resistance. The point is nothing but the expressing the formula, nothing but they're saying the formula in terms of words. The equivalent star resistance connected to a given terminal is equal to the product of two delta resistance connected to the same terminal divided by the sum of the delta connected resistance. If the delta connected system has same resistance R at its three sides, then equivalent star resistance R will be smaller is equal to R into R by R plus R plus R. So we'll get R square by 3R. If we cancel by using a mathematical calculation, we'll get R by 3. So delta to star transformation equation. So this is the equations to transform from delta to star transformation equations. P is equal to AB by A plus B plus C. Q is equal to AC by A plus B plus C. R is equal to BC by A plus B plus C. If the three resistors in the delta network are equal in the value, then the resultant resistors in the equivalent star network will be equal to 1/3 the value of the delta resistors. This gives each resistive branch in the star network a value of R star is equal to 1/3 into R delta, which is the same as saying R delta by divided by 3. Delta star example number 1. So here is the example for the delta star conversion problem. Convert the following delta resistive network into an equivalent star network. So here we have a formula. Q is equal to AC by A plus B plus C. So 20 into 8 divided by 130. By mathematical calculation, we get 12.31 ohms. Similarly, to P is equal to AB by A plus B plus C is equal to 20 into 30 by 130. We'll get 6 by 13 on the 60 by 13 on the calculation. We get 4.61 ohms. R is equal to BC by A plus B plus C. So we get 30 into 80 by 130. If we have a mathematical calculation, we get 240 divided by 13. So here we get 18.46 ohms. So here is example number 2 for the delta star conversion. Let us calculate the resistance of the star network, which are equivalent to the delta network as shown in the following figure. So here we have a delta diagram and a star diagram. Here we have to convert delta to star transformation. We have R1 is equal to 10 ohms and R2 is equal to 60 ohms and R3 is equal to 30 ohms in the diagram of delta. And in the diagram of the star, we have RA, RB, RC as represented as RA. Resistance are represented as RA, RB, RC. So given the resistance of the delta network as R1 is equal to 10 ohms, R2 is equal to 60 ohms, and R3 is equal to 30 ohms. We know the following relations of the resistance of the star networks in terms of resistance of the delta network. So this is the formula for the conversion of delta delta to star, R is equal to R1 R2 by R1 plus R2 plus R3, and R is equal to R2 R3 by R1 plus R2 plus R3, and RC is equal to R3 R1 by R1 plus R2 plus R3. On substituting all the values in the given formula, substitute the values of R1, R2, R3 in the above equations. R is equal to, then we get 10 into 60 by 10 plus 60 plus 30, we'll get 600 and 100, and we get 6 ohms. RB is equal to 60 into 30 by similar to the above one is 100. 1800 divided by 100 is nothing but 18, and RC is equal to 30 into 10 by 10 plus 60 plus 30. We'll get 300 by 100. We'll get 3 ohms. So we got the resistance of star network, nothing but as RA is equal to 6 ohms, RB is equal to 18 ohms, and RC is equal to 3 ohms, which are equivalent to the resistance of the given delta network. So for the conversion of delta to star, so we have a mean formula which we need to remember is nothing but RA is equal to R1 R2 by R1 plus R2 plus R3, and RB is equal to R2 R3 by R1 plus R2 plus R3, and RC is equal to R3 R1 by R1 plus R2 R3. So the methods for reliability evaluation of a complex system using delta star transformations have been developed by several authors. They give approximate results because the basis on which the transformation is derived is not correct. These transformations can be carried out under certain conditions. Notation SI. Sets of branches including the branches forming the delta connected to node I. Rij. G. Reliability of the component connected between nodes I and J. Q not Ij. Probability of open circuit failure of the component connected between nodes I and J. QSIJ. Probability of short circuit failure of the component connected between nodes I and J. RT is nothing but a system reliability. So conditions of transformation. In a delta star transformation, 3 independent conditions are to be imposed, as there are 3 elements to be determined as assumptions. The component of states are dependent. The branches of one set out of sets S1, S2, S3 have flow into the corresponding nodes. So here we have a reliability diagram, subsystem A and input node. So these are the conditions for transformation. In the delta star transformation, 3 independent conditions we have. The assumptions are the component states are dependent. The branches of one set out of sets S1, S2, S3 have flow into the corresponding nodes, etc. So the reliability the reliability before and after the transformation is the same. Between the node 1 and node 2 and 3, when all 3 sets are present. Between node 1 and 2, when S3 is null set. Between node 1 and 3, when S2 is null set. Reference 1, 3 do not satisfy condition 3A. Also, the expression derived for conversion in 1, 3 apply only when condition 2 is satisfied. If there is no restriction on the flow outside the delta, then 6 conditions are to be satisfied, and hence transformation will not be possible in delta. So these are the 3 main conditions in the node 1 and the nodes 2 and 3, when all 3 sets are present. Between nodes 1 and 2, when the S3 is a null set. Between the node 1 and 2, when the S2 is null set. Between 1 and node 3, when S2 is a null set. So general two-state device network. Consider, for example, 3 components. Each component has 2 states. Example: operating and failure of a system which reliabilities R13, R12, R32 connected to form the delta configuration shown in the figures 1 and 2. This configuration can be transformed into star equivalent with the reliabilities R10, R20, R30. Applying S independent event probability loss to series and parallel components results in 1, 2, 3, R10. So this is a basic two-state device network. How does it work? General note. So solving 1, 3 for R10, R20, R30 results in the relations for delta star transformations. The third one is the three-state device network. The delta to star equivalent of a network consisting of three-state devices. Example, operating short circuit failure, open circuit failure can be obtained in the same manner as two-state component case. The expression of like equivalence for the open mode failure case. So three-state device network can be done in the same approach of the two-state device network. Similarly, the expressions for the leg equivalent for the short circuit failure cases are given as follows. For example, consider the bridge network as shown in the figure 3. So evaluating reliability of this bridge structure with the event space method yields the same expression for the system reliability. So yeah, thank you. This is the delta star conversion tech talk of physics. Thank you.